Welcome back to the channel. In this video, we will be creating a new program in TI Basic to simplify square roots. This smaller program will be a part of more programs to come in future videos, so stay tuned. To get started, hit the Program button and create a new program called RootSimp. Then as always, start your program by clearing your home screen. We are only going to input one number for this program, and the goal will be to simplify the square root of that number. So here we have one input command for a number n. The first part of this program is just an if-then statement to check for non-real solutions if the user inputs a negative number. This next part will be to check for the denominator of the number we input. For most cases, it will be 1 if you input an integer, but if you want a simplified root of a fraction, this while loop will run until it finds a denominator value d that gives an integer when it's multiplied by n. The way it works is by storing a value of 1 into d and then checking if the fraction part of n times d is equal to 0, meaning that it is an integer. If it fails, it adds 1 to the value of d until the denominator is found. You'll notice that I'm also using the round function, and I will continue to use it in the rest of this program. This is because sometimes your calculator memory will store a repeating decimal like 0.9 repeating, and that means the fraction part won't be 0. By rounding the answer to 5 decimal places, it covers cases where your calculator stores values with repeating 9s when it really should be an exact integer. You can find the fpart command and the round command when you click the math button and scroll over to the num section. Round is the second option and fpart is the fourth option. We just found our denominator, which is 1 for most cases when we input an integer, but in the case of a fraction, we can't run it through the loop since we need a whole number. So we take our original number n and multiply it by d squared and then store it into a new variable m. For example, if we started with 1/4, multiplying by 4 squared scales it up to a clean integer. Again, we will be using the round command to get rid of any numbers with repeating 9s. Next, we set up our starting variables. A is going to be the number on the outside of our square root, and b is going to be the number on the inside. Because we haven't simplified anything yet, we set our outside number a to be 1, and we set our inside number b to be m, the integer we just calculated. Now that we have our number set up, we can use a for loop to simplify the square root. Here's what's going on. We are telling the calculator to start checking numbers starting from the square root of our number m and counting down to 2, subtracting 1 each time. The reason we stop at 2 is because if we go to 1, no matter what number we input, it will always be divisible by 1, which is also 1 squared. So we can exclude it to have an implied 1 for a root that can't be simplified further. We have it count backwards, so the first perfect square that it finds is also the largest perfect square that fits into our number m. Also notice that we have another round command in there to prevent the calculator from getting rid of repeating decimals. Once the loop reaches a value of I that when squared is perfectly divided by m, it means it found the largest perfect square. This value of I is then stored into a, and the new math m divided by I squared is stored into b. Now I'm going to show you a trick to save time and memory. Normally this loop would keep counting all the way down to 2, but instead we're going to store 0 into I, which forces the loop to end. Finally, we put 2 end commands to close the if-then statement and the for loop. Now that we have our simplified numbers a and b, we just need to display them in radical form. But before we do that, remember when we had to scale up our number n by multiplying it by d squared? Now we have to undo that by dividing a by d, since the square root of d squared is just d. Finally, getting into our displays, there are 3 cases: a equals 1, b equals 1, and all other cases. Remember that our final answer is in the form a root b, so our first condition will be if b equals 1, then we just want to display a. A personal preference is to add the fraction command after the variable in your display. You can find it by clicking the math button, and it's the very first option. Next, we can use an else if statement for when a equals 1 to display the square root of b, again using the fraction command. And finally, we can put an else statement for all other cases to display a root b. Just put two end commands since we have two thens in this block, and we can check to see that our program works. Let's first check scenarios where we input a perfect square, like 25, and as you'll see, it will output the number 5. If we try a number that can be simplified, like 12, we'll see it will output the answer in simplified radical form. Then if we test a fraction, like 1/4, it will go through the loop to find that the denominator isn't 1, and it will display 1/2. Finally, if we test a fraction that isn't a perfect square, like 1/6, it will display the answer in simplified radical form, 1/6 root 6. So that's it for today covering the square root simplifying program. As I said before, this program will be a part of more programs to come in the future, so make sure you know where to find this video. I'll see you in the next one.